In this video lecture, we are going to see revision of the chapter Real Numbers. Now this video I'm making for you all, as I am aware that in your schools formative assessments, FAs and formative assessments ones are going on, and you all will need revision for the chapter Real Numbers. And even if FAs and essays are not going on, you need to prepare for the final exams, and this chapter is important. So here's a quick revision for the chapter Real Numbers. But before proceeding, if you like my content and if you are understanding my videos and if you benefit, if you are able to solve the sums easily by understanding my videos, then please don't forget to subscribe to my channel and also hit the like button, and also share this video with your friends, because if you share the video with others, God will help you. Okay, so let's continue. So in real numbers, the first concept is division algorithm, or Euclid's division lemma, or Euclid's lemma. So what is Euclid's division lemma? If we consider there are two positive integers a and b, then there exists unique pair of integers q and r satisfying a is equal to bq plus r, where 0 is less than or equal to r is less than b. What is this? If you observe here, it is nothing but it is dividend is equals to divisor into quotient plus remainder. Here's a quick review from the last video I had made earlier, and that video in detail, if you want, you can check by clicking the link which is showing here. In that I have explained in detail what is Euclid's division lemma and a problem on Euclid's division lemma also. So if you observe here in this diagram, dividend is equals to divisor into quotient plus remainder, that is same as a is equals to b into q plus r. That is, if we are having two integers a and b, then for that two integers a and b, you will have a specific quotient and a specific remainder, and that remainder should always be less than the divisor but should be more than or equal to 0. Now what is the use of this division algorithm? This division algorithm can be used to find HCF of 2 or 3 numbers. Now this HCF is also called as GCD or GCF, that is greatest common divisor or greatest common factor. Let us solve an example of Euclid's division algorithm. For example, in the question it asks us find the HCF of 60 and 100. So how to find the HCF of 60 and 100 by Euclid's algorithm? So always remember, the hint is between the two numbers, take the smaller number as the divisor, that is keep it as outside, and take the bigger number 100 as the dividend, that is keep it as inside in the division. So 60 is my divisor, 100 is my dividend. Now 60 ones are 60. We know 100 minus 60 is 40, because this will become 0 and this will become 10. 10 minus 6 is 4. Now 40 will be there, right? Whatever here you are having 60. This will become dividend now, and this 40 will become divisor. So 40 ones are 40. 0 minus 0 is 0. 6 minus 4 is 20. Now 20 we got. 20 will become divisor and 40 will become dividend. So 22s are 40. So 40 minus 40 is 0. So whenever I get the remainder as 0, I should stop there, and the divisor b at this particular stage will be my HCF of the two numbers. So here, as this is my last stage and here I am getting the remainder as 0, my HCF of 60 and 100 is 20. Hope you have understood this example of Euclid division algorithm. If you have any doubt in this Euclid division algorithm or procedure, then please feel free to comment in the comment section. Now the next method is prime factorization method. Prime factorization method is a method of finding which prime numbers multiply together to make the original number. For example, 12 is an original number here, and that can be expanded as 2 into 2 into 3. That is, 2 and 3 are prime numbers here. So whenever we can expand the original number as a product of prime numbers, then it is called as prime factorization method. Now this prime factorization method, as you got to know just now what it is used to find out HCF as well as LCM. Euclid's algorithm was used only to find out HCF, but prime factorization is used to find out both HCF and LCM. And one more thing, this HCF can be either found out by Euclid's algorithm or it can be found out by prime factorization method. It depends on the question being asked. If the examiner asks you to solve by Euclid's algorithm, then find HCF by Euclid's algorithm. only. If the examiner asks you to find out HCF by prime factorization, then use prime factorization to solve HCF. But LCM, only you can solve by prime factorization according to your 10th standard syllabus. So here, let us solve an example in order to find out how to find out HCF and LCM by using prime factorization method. So the question is, find HCF and LCM of 54 and 12 using prime factorization method. So 54, if I know that 54 is having unit 0 as 4 and it will go in 2 table. So 2 2s are 4, 5 minus 4 is 1 4, 2 7s are 14. Now here 27 will go in 3 table, 3 9s are 27, 3 3s are 9, 3 1s are 3. So here I got 54 is 2 into 3 into 3 into 3. Let's find out the prime factorization of 12. 12 will go in 2 table. 2 6 are 12, 2 3s are 6, 3 1s are 3. Always remember, in prime factorization method, you should use only prime numbers as you can see in this example. What are prime numbers? Prime numbers are the numbers which are divisible by 1 and itself only. Prime numbers won't go in any other table. They will only go in their table only, or they will only go in one table. So in prime factorization, use only prime numbers. Okay, so here also if I'm using HCF, if I have to find out HCF and LCM by prime factorization, means see here I am using prime numbers 2 and 3. Prime numbers 2 and 3. Any number prime number you can use, but you have to use prime numbers only in prime factorization method. You cannot use 4 because 4 is a composite number. Okay. So now 12 can be expanded as 2 into 2 into 3. 2 into 2 into 3. So here, what is HCF? Remember, I'll give you a hint. HCF is always only common between 54 and 12 factors. That is, what are the factors of 54 I have? 2, 3, 3. Now, what are the factors of 12 I have? 2, 2, 3. So, 2 is there in 54 as well as 2 is there in 12. So, my HCF of 54 and 12 will be equal to, between this 2 and between this 2, I should take 1, 2 common. Now, between this 3 and this 3, I should take 1, 3 common. So, 2 3s are 6. So, HCF of 54 and 12 is 6. Now, let us find out LCM of 54 and 12. So, what is the hint here? The hint is always take the common numbers. See, here I did not choose 3 again. Why didn't I choose 3 again? Because 3 only one time is there. So, from this 1 3 and from this 1 3, I'll take 1 3 common. And from this 1 2 and from this 1 2, I'll take 1 2 common. I don't have any other numbers, so I cannot take anything as common. So HCF means only commons. LCM means commons as well as leftovers. There is between this 2 and between this 2 you are taking 1 2 common, and again between this 3 and this 3 you are taking 1 3 common, and whatever is left, that also you have to take. So here you can take 2. What are remaining? 3 is remaining, 3 is remaining and 2 is remaining. So already we wrote common numbers. There is 2 and 3 are common between these both. Remaining are 2 into 3 into 3. So what is the LCM of 54 and 12? Multiply. 2 3s are 6, 6 2s are 12, 12 3s are 36, 36 3s are 3 6 are 18, 3 3s are 9, 9 plus 1 is 10, 108. So this is how you find out LCM and HCF by prime factorization method. What is the hint? I'll write the hint here for your better understanding. Remember it. HCF means only commons. LCM means commons as well as leftovers. Now you have a more important concept related to HCF and LCM. Okay, that is, when I take the, suppose HCF of two numbers is given to us and LCM of two numbers is given to us in the question. Then if you multiply that HCF and LCM, you can find out the product of the two numbers. Okay, that is HCF and LCM of two numbers is equals to product of the numbers. For example, there are two numbers A and B. A and B here are real numbers. Remember this formula. HCF of the two numbers into LCM of the two numbers is equals to product of the two numbers. I'll apply the same formula for this numbers. HCF I got is 6. Right? And LCM I got here is 108. What is the number given to me? A 54 I'll consider, and B I'll consider as 12. So find out what is 108 into 6. 108 into 6. 6 8s are 48. 4 is 4. 6 1s are 6. 648. And what will I get when I multiply 54 and 12? 2 4s are 8. 2 5s are 10. 1 4s are 4. 1 5s are 5. 8 4 6. 648. See, I said. Remember this formula. There is HCF of two numbers into LCM of two numbers is equals to the product of two numbers. Okay, HCF for example is 6 of the two numbers. LCM for example is 108 for two numbers. Then whatever answer I'll get here will be equal to the product which I get when I multiply both the numbers. Okay, 648 is equals to 648. This is the proof that this concept is true. Let's move to the next concept. That is fundamental theorem of arithmetic. What is fundamental theorem of arithmetic? Fundamental theorem of arithmetic states that every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. I'll explain this theorem. It's very simple. There is whatever, suppose you're taking a composite number, a big composite number, okay? Now, what are composite numbers? Composite numbers are the numbers which are opposite to prime numbers. That is, composite numbers have more than two factors. For example, 6 is a composite number. Why 6 is a composite number? Because 6 is equals to 6 into 1 and also 6 is equals to 2 into 3. There is 6 has factors 1, 2, 3. That is, it is having more than two factors. So, any number which has more than two factors is called as composite number. So, every composite number can be expressed. That is, when I open it, it can be expressed or it can be factorized as a product of primes. Product of primes means, for example, here I am having a number. If I open it, all these numbers should be prime numbers and those will be a multiplication. See here, into sign is there and I am having prime numbers. These are product of prime numbers. So this composite number can be expressed as product of primes, and this factorization is unique. Unique means we cannot get any other numbers. We'll only get 2, 3 and 5 here if we do prime factorization. We cannot get 7, we cannot get 17, we cannot get any other prime numbers. We will only get this prime numbers. This is unique. There is only these prime factors you will get. Okay. But the order can be anything. For example, here I am having 3 into 2 into 5 into 3 into 3. So here, before also I can take 2 into 2 into, then I can take 3 into 5 into 2. There is order can be different. But only these prime factors I will get, and that will be a product of prime numbers. So, see, this is very beautiful theorem, right? Composite number can be expressed as product of prime numbers, primes. Take an example of a composite number as 27,300. Here, 27,300 is a composite number. Now, when I do the prime factorization of a composite number, I should choose only the prime numbers, right? This is a composite number, I'm choosing prime numbers. For example, this is 27,300, right? Since I have 3 here, it will go in 3 table. 3 9s are 27, 3 1s are 3, 3 zeros are 0, 3 zeros are 0. 2 4s are 8, 9 1 is 0 is 1 1, 2 5s are 10, 1 0, 2 5s are 10, 2 zeros are 5, 9s are 45, 5 1s are 5, 5 zeros are 5 1s are 5, 9 1 is 5 is 4 1, 5 8s are 40, 1 0, 5 2s are 10. 2 9s are 18, 2 1s are 2, 7 1s are 7, 9 minus 7 is 2 1, 7 3s are 21, 13 1s are 31 as 13 is a prime number. So, what did I get? I can express this 27,300 as 3 into 2 into 5 into 5 into 2 into 7 into 13. That only I have written. Now, 3 is only one time, so I'll write 3. And 2 I can write as, since I have 2 times 2, 2 squared. And here, since I have 2 times 5, I can write 5 squared. Then 1 times 7, 1 times 13. What did you observe? This is nothing but product of prime factors. There is prime factors means the factors which are prime numbers are called as prime factors. So here we can see that when we open this composite number, we are getting all these numbers can be written as multiplication of prime factors. There is factors of prime numbers. Theorem is, let x is equals to p by q be a rational number whose decimal expansion terminates. Then x can be expressed in the form of p by q, where p and q are co-prime, and prime factorization of q is of the form 2 power n into 5 power m, where n and m are non-negative integers. That is, n and m should be positive integers here. And suppose if I convert this rational number in terms of decimal, then the decimal expansion which I get is terminating. Terminating decimal expansion means when I divide that rational number, I should get the remainder as 0. That is, for example, terminating decimal is 0.645. That is, after 5, I don't have any other number. So that is a terminating decimal expansion. So whenever a number has a terminating decimal expansion, then the denominator of this rational number, p by q, can be expressed in the form of 2 power n into 5 power m. That is, 2's and 5's product should be there when a decimal expansion is terminating. Now next theorem is opposite of first theorem. That is, in the earlier theorem we saw that if decimal expansion is terminating, then denominator is in the form of 2 power n into 5 power m. Here, suppose in the question we have that the denominator, that is q of p by q, prime factorization is of the form of 2 power n into 5 power m, and here also n and m are non-negative integers, then that number x will have a terminating decimal expansion. In short, if I can say that if the denominator has 2 power n into 5 power m decimal expansion, then compulsorily the decimal expansion is terminating. That is, the remainder is 0 whenever denominator is in the form of 2 power n into 5 power m. If you want problems based on these theorems, there are there in the playlist of real numbers on our channel. You can go and watch, and also it is showing in the link displayed here. Click that link and find out in detail about it. The next theorem is let x is equals to p by q be a rational number such that the prime factorization of q is not of the form 2 power n into 5 power m, where n and m are non-negative integers. Then x has a decimal expansion which is non-terminating repeating, or it can also be non-terminating recurring. Recurring and repeating both have the same meaning. That is, if you observe in this theorem, it is telling that suppose a rational number is there x, okay, and that can be expressed as p by q form, and the denominator of q is not of the form 2 power n into 5 power m. That is, the denominator will not have factors of 2, or will not have factors of 5, or will not have factors of 2 and 5. Then if it is not, q is not of the form 2 power n into 5 power m, then x will have a decimal expansion which is non-terminating repeating. That is, you will no longer have remainder as 0, and suppose example non-terminating repeating is 0.456789234. That is, it is going on, and also the numbers will not repeat, and also remainder will be 0. That is, it will be non-terminating repeating if q is not of the form of 2 power n into 5 power m. Now let us move to the next theorem. Let p be a prime number. If p divides a square, where a is a positive integer, then p divides a. For example, it is saying that when p divides a square, that is, p divides the square of a number, then p also divides a. What is p here? P is a prime number. That is, prime number is dividing the square of a number, then prime number also divides the number. For example, if I consider p is equals to 2 and a square is equals to 1, I have, then square root of this square, when it goes outside, becomes square root, right? So a is equals to square root of 1, so a is 1. A square is also 1, a is also 1. There is, this 2 will also divide 1, and this 2 will also divide 1, because a square is also 1 here and a is also 1. Now for example, let us take a prime number is 2 and the square of a number is 4. Then how to find out square root of 4? We know square and it goes outside, becomes square root. Square root of 4 is 2. So that is, this 2 will divide a square, that is 4, because 2 ones are 2, 2 twos are 4. This 2 is dividing 4 as well as 2 is dividing 2, right? Because it will be divisible, right? 2 ones are 2, 2 ones are 2. There is 2 divides a square, that is p divides a square, and also p divides a. I'll give you one more example. See here, p is equals to 5, that is, a prime number I am choosing is 5, and the square of a number I am choosing is 25. Then how to find out a from this? Square, when it goes outside, it becomes square root. So square root of 25 is 5. So a square is 25 and a is 5. That is, here if I divide this 5p with the square of a, that is 25, I'll get the remainder is 0. That is, both are divisible, right? 5 and 25. That is, 5 can divide 25 as well as 5 can divide 5, because 5 ones are 5. Okay, that is, what I mean to say from this theorem is that if the prime number is dividing the square of number, then the prime number should also divide the number. Now let us come to some beautiful concepts. Okay, that is, here for example I have the sum or difference of a rational and an irrational number is always irrational. This is very important for you to remember. Okay, remember, whenever we add two one rational and another irrational number, then we should always get an irrational number. Or whenever we subtract a rational number and an irrational number, we should get an irrational number. For example, rational number plus irrational number. For example, let us consider that my rational number is 2 and my irrational number is root 2. When I add both, can I add both? 2 plus root 2 can be expanded as 1.414 and so on. This number will go on. This is the value of root 2. There is I cannot add both 2 and 1.1414. There is 2 plus root 2 cannot be expanded. So 2 plus root 2, as I have root 2 here, it is an irrational number. So with example, I have shown you that when I add one rational number and one irrational number, the result I'll get is always an irrational number. Similarly, let us see what will happen when I subtract one rational number and one irrational number. When I subtract one rational number and another irrational number, for example, let us consider rational number is 2 and irrational number is root 2. 2 minus root 2, again root 2 can be expanded as 1.414 and so on. So I cannot subtract both. So it can be written as 2 minus root 2. That is 2 minus root 2 here is an irrational number. Right. So if you observe here, we can see that root 2 is coming. As root 2 is coming, the whole number is an irrational number. So what did I get? There is when I subtract one rational and one irrational number, I'll get an irrational number. Okay. Now let us see the next one. The product or quotient of a non-zero rational and an irrational number is irrational. What it means is that when I multiply a rational and an irrational number, or when I divide a rational number and an irrational number, here I will always get an irrational number. Okay, rational number means it will have root. Okay, it cannot be expressed in the form of p by q. That number is called as irrational. For example, I am considering my rational number is 3 and my rational number is root 5. Can root 5 be expanded? No. Root 5 cannot be expanded. Root 5 can be written as 2.236 and so on. So when I multiply both, they cannot be expanded, right? So 3 into root 5 is 3 root 5 only. As root 5 is there, it is a irrational number. So remember, when I multiply a rational number and an irrational number, I'll get an irrational number. Similarly, let us apply. It is saying quotient also now. That is when I divide a rational number and an irrational number, also I'll get an irrational number. Example, I'm taking a rational number as 3 and I'm taking an irrational number as root 5. When I divide rational number and an irrational number, we know whenever root in denominators, to rationalize that number, we should multiply and divide by root 5. That is, we should rationalize, we should multiply and divide by the denominator. So here 3 into root 5 is 3 root 5 and root 5 into root 5 is 5. Now if you see here, 3 by 5 can be expressed as 0.6 if you divide 3 by 5. So again we are having 0.6 into root 5 because root 5 is a rational number. Here as I am having a root, it is an irrational number. The sum of two irrational numbers need not be irrational. Okay, that is, this is different. If I take two irrational numbers and add them, it is not necessary that I will get the result as an irrational number. I may get a rational number or I may get an irrational number. For example, I am considering my irrational number is root 2 and another irrational number is minus root 2. So when I add both the irrational numbers, that is root 2 as it is, plus into minus is minus. So root 2 minus root 2 is 0. 0 can be written as 0 by 1. So 0 by 1 can be expressed in the form of p by q. So p by q is rational. So what do I observe here? That is when I add two irrational numbers, I am getting the number as rational. Let us take one more example. For example, A is root 5 and B is root 3. When I add root 5 and root 3, root 5 can be expressed as 2.236 and so on, and root 3 can be expressed as 1.732 and so on. So, if you observe here, this 2.236 is root 5 and 1.732 is root 3. So, here I cannot add both. Roots are there now and the values are different and they are non-terminating, repeating. Non-terminating, non-repeating. So, the result I am getting is an irrational number. That is when I add two irrational numbers, I may get an irrational number, or when I add two irrational numbers, I may get a rational number. Now, the product of two irrational numbers need not be irrational. That is, just now what we discussed is sum of two irrational numbers. Now, let us see what will happen when you multiply both the irrational numbers. When I multiply one irrational number and another irrational number, what will I get? For example, let us consider one irrational number is root 2 and another irrational number is 3 root 2. When I multiply both 3 as it is, root 2 into root 2 is 2. 3 2s are 6. 6 can be written as 6 by 1. So it is a rational number because it can be expressed in the form of p by q. So what do I observe here? When I multiply both irrational numbers, I am getting the answer as rational. Now let us take one more example. Let us take one number is root 7 and another irrational number is root 6. Both are irrational numbers. Now root 7 into root 6, if I want to multiply, I can write root and 7 6 are 42. Okay, but still what we will get, see, observe here. 42 can be expanded as 2 2s are 4, 2 1s are 2, 3 7s are 21, 7 1s are 7. There is root 42 can be written as root 2 into root 3 into root 7. Why root? Because only one number is there. One time means it will always be in root. So again, root 2 is an irrational number, root 3 is an irrational number, root 7 is an irrational number. So I am getting the answer as irrational number only. So what did I observe here? There is, even if I multiply two rational numbers, I may get a rational number, or when I multiply two rational numbers, I may get a irrational number only. That is, it is not necessary that when I multiply or when I multiply two irrational numbers, I'll get the answer is irrational. Say what the conclusions which we have got from this so that you can remember it well. The first statement we discussed is, for example, my first number is a rational number. That is, it is in the form of p by q, and another number is irrational number. So when I add a rational number and an irrational number, I will always get an irrational number. You have to remember this. It can ask anytime in the questions, in the objectives. Then if I subtract a rational number and an irrational number, always I will get an answer as irrational only. Okay, that is when one number is rational and another number is irrational. Even if I add the number or even if I subtract those numbers, I will always get the answer as irrational only. That is, it will be in the root form only. That is, it will not be in the form of fraction p by q. Now, third one we got is, if one number is rational and other number is also irrational, and if I multiply them, still I'll get the answer is irrational. Just now, whatever we discussed, I'm just giving you the statements for you to understand and remember. So you can note down this in your book. Okay, one more thing I forgot to say before starting this video is that please, whatever I'm saying, note this down in your books, because these are important and these concepts and formulas will be used in solving the sums. So take a pen and take a book and sit and write whatever am I saying in the video. If you have missed the previous things, whatever I said, just rewind the video and see it. Now, similarly, when I divide one irrational number and another irrational number, I will get the result is an irrational number. The fifth concept is, suppose if two numbers are irrational and if I add them, it is not necessary that I will get an irrational number. That is, I may get a rational number or I may get an irrational number. That is why I am putting oblique. It is not necessary that I will get an irrational number when I add both the irrational numbers. The sixth concept we got is, when we multiply two irrational numbers, it is not necessary that I will get the answer as an irrational number. I may get a rational number or I may get an irrational number. See, I'll just quickly say in 1 minute whatever I have wrote here. From 1 to 4, if you observe, if the numbers are rational, one number is rational and another number is irrational, always the answer I will get is irrational. Whether I add both the numbers, that is rational and irrational, or whether I subtract rational or irrational, or whether I multiply rational or irrational, or whether I divide rational or irrational, always we will get the answer as irrational. But on the contrary, if we take two irrational numbers, right, then if we add the two irrational numbers, it is not necessary that my answer will be irrational. I may get a rational number as we saw in the example, or we may get irrational numbers. Similarly, if we multiply two irrational numbers, it is not necessary that we will get irrational number. I may get a rational number, I may get an irrational number. That is what I mean to say. Please take a screenshot of this or write this in your books and learn this so that if it asks in exam, you can easily remember and write. Last concept in real numbers, that is laws of exponents. This will be used in many problems, okay, and these are the basics of maths. These are the strength of maths, okay. For example, I'm having a power m into a power n. What is a power m into a power n? A power m into a power n is a power m plus n. A power m divided by a power n is a power m minus n. AB whole power m is equals to a power m into b power m. That is, if m belongs to a and b both, it means m belongs to a as well as m belongs to b. Similarly, a by b whole power m is equals to a power m by b power m. That is, if m belongs to whole a by b, then m belongs to a as well as m belongs to b. Now, a power m whole n is equals to a power mn. That is, if n is there outside the bracket, then n can also be multiplied with the power that is inside the bracket. See, m and n are getting multiplied here. Then the value of a power 0 is always 1. And then a power minus m can be written as 1 by a power m. That is, if minus is there in the power, then we can send this power down in the new denominator, so it will become positive. I'll give you example for this, okay. Here, a power m into a power n. For example, I'll take a is 2 here and m is 3. and a is 2 here and n is 4. So 2 power 3 into 2 power 4 is of the form of a power m into a power n. What is a power m into a power n? A power m plus n. So a is 2 here, m is 3 plus n is 4. So 2 power 3 plus 4 is 7. 2 power 7 is my answer. Similarly, a power m by a power n. Similarly, I will take the same example. 2 as a, I'll take m as 4 here and I'll take n as 3 here. So it is in the form of a power m by a power n. A power m by a power n is a power m minus n according to the formula. So 4 minus 3 is 1. So 2 power 1 is 2. So my answer is 2. Similarly, here I will take a is 2 and b is 3 I will take. So 2 into 3 whole power m. M here I will take as 2. Okay. Now this 2 belongs to 2 as well as this 2 belongs to 3. That is, it can be written as 2 square into 3 square. So 2 2s are 4, 3 3s are 9. 2 square means 2 2s are, right? That's why 2 2s are 4 and 3 square means 3 3s are. So 3 3s are 9. 4 9s are 36. So my answer is 36. This example now. A I'll take for example is 10. B I'll take for example is 5. Power m I'll take example is 2. So if 2 belongs to 10, then 2 also belongs to 5. So 10 square by 5 square. 10 tens are 100 and 5 square. 5 5s are 25. So I'm getting 10 by 25. That is 2 by 5 2s are 10, 5 5s are 25. 2 by 5 is my answer. Similarly, I'll give this example also. A I'm considering as 2, m I'm considering as 3, whole n I'll considering as 2. Okay. Now, if 2 is there in the bracket, it can be multiplied with this 3, right? Because it is the form of a power mn. A power m whole n is equals to a power mn. So 2 power 3 into 2, 2 power 6 is my answer. We can expand this 2 power 6 if you want. You can write there. Here also you can expand 2 power 7 and write the value you are getting. 2 power 6 means 2 6 times. Okay, that is 2 into 2 into 2 into 2. Whatever value you are getting, you can write here. Now a power 0 is 1. For example, a I am taking as 2. 2 power 0 value will always be 1. Don't think 2 power 0 is 2. Because it is power 0. Or I'll take one more example. 3. 3 power 0 is also 1. 4 power 0 is also 1. 7 power 0 is also 1 because it is in the form of a power 0. A power 0 is always 1. Similarly, let us take one more example. A power minus m is equals to 1 by a power m. A is 7 for example. Power minus m. Minus m means for example 7 power minus 2 is there. It is of the form of a power minus m. So a power minus m is 1 by a power m. So 1 by 7 square. 1 by 7 square is 1 by 49. Okay. So hope you have understood all these law of exponents. Similarly, write these law of exponents. And now in the next video, we will be seeing logarithms, that is logs. Okay, since the video is becoming very long, I do not want to bore you all. So I am not included logarithms here. Logarithms we'll see separately. Logarithms are also very easy. We'll solve some questions in that. Okay. Thank you very much for watching. Stay blessed. And if you have understood all this content of mine which we have discussed today, and if you have even understood 1%, then please like the video, subscribe to this channel and share this video with your friends, and also comment if you have any doubt. Thank you very much. Stay blessed.